Hi, welcome to Short Talk. I'm Aki Fujimura. I'm CEO of D2S, which is the managing company sponsor of the eBeam initiative. We're here today at this beautiful facility, Robert Noyce Building at Intel, and we're here with Frank Abboud. He needs no introduction, I know, but he is in charge of IMO, everybody knows IMO, Intel Mask Operations. Frank, welcome.
Thank you. Welcome. Glad to have you here.
Thank you. Thank you very much.
Thank you for coming.
Yeah, so we just came out of Bacchus, right? And
Yes.
It was fun. It was really a good conference, I thought. And you were very nice to give honoring Hayashi-san of the NP, who is retiring this year. He talks about how he came to America the first time to visit ETech. Say a little bit about that.
Yes, absolutely. Yeah, I'm really happy to be part of the Hayashi-san tribute to his retirement, and thank you for putting that at the event. Hayashi-san leaves a very, very nice legacy behind him in mask making and equipment development. Now, he came to Hayward at the time. In 1979, it's a few years ahead of me. I came many years after. I think he was accepting MEBUS number 14, and when I joined, we were shipping MEBUS number 50. But the story goes is he came in for a month to accept the MEBUS, and as you remember, the MEBUS was like the #1 mask writer at the time. And he didn't like it. I guess he didn't like the spec. He didn't like the performance. So 4 weeks later, he leaves back to Japan. And then 6 months after that, the company invites him to come back, and he comes back to accept the machine. And it wasn't good enough yet. So he ended up spending 4 months before he can take it. So, and I have to say, during my time with ETech and PerkinElmer, this is not like an odd story. We had many cases where Japanese customers would come in and stay for a while. The machine was good, but there was a lot of analog electronics.
Right.
And many things are not deterministic, so a lot of tuning. But it was wonderful to see him and to have a chance to say goodbye to him.
Yeah. That was very nice of you. So you mentioned PerkinElmer. Is that where you started your career?
Yes. I started with PerkinElmer.
What did you do?
I started as an engineer. I had or still have, master's in electrical engineering, PhD computer science, and was hired to help in the MEBUS system. And at the time, MEBUS had a raster engine that would take the CALMA format and turn it into a bitmap. And it was called Minicon. It was designed out of discrete hardware from AT&T Bell Labs, and it was very slow. So with my expertise, my job was to make a new raster engine that's modern. And I recall at the time it had the marketing name of high throughput memory. And it was made up of parallel processing. I mean, we actually did parallel processing at the time when not many people were talking about it. And they used Motorola 68000 processors. No GPUs at the time, but we did use double port memory, and we had multiple bands of that memory. So we would take the CALMA or the GDS data, subdivide it into multiple bands, and have the processors run, and then they will all merge into the memory. And then you would flip back and forth between memory banks based on once one is done, you prime the pump, and then once one is done, it starts feeding the beam while you're rasterizing into the other one.
Wow.
And I think it tripled the throughput of the machine, and I think at the time...
So that's how you started?
That was my claim to fame.
This is like the Motorola 68000, so this must be like 40 years ago, right? Like 1980, early 1980s, I remember.
No, it
No?
was
Later?
I think it was like 88 or 87.
Okay, okay.
Yeah, but at the time
so
we were
35 years ago.
yeah we were able to buy the full boards rather than actually design every chip, along the main CPU.
Yes. Now we use GPUs for this stuff, but you right you were like basically well prepared for the world that was about to come 2 generations of machine architectures later with multi-beam then, right? I mean,
Pure
you
luck.
knew exactly. But you were early in recognizing IMS as
Yes.
having the multi-beam technology, and it's a well-known thing that you were a very strong supporter from the time that they were independent company, and so this background must have given you the confidence that you know what they should do and you know that it's going to work. No,
Yeah, absolutely. I think at the time it was like in late 2007 or 2008. We knew that the vector shape beam is going to hit a wall. And I may have said this in one of the conferences in the past because I always attribute things to luck, a little bit to luck. We were so worried about ILT, inverse lithography,
right.
to become the mainstream. And we knew that the vector shape beam tools will have a problem. We'll have a problem with throughput and would not be able to keep up. And it may hinder the advancements in litho. So I think it was 07 or 08, we started a survey of all the multi-beam writers in the world. And we did a very comprehensive research. We looked at the KLA Thincore machine. We looked at Mapper. I think Advantest had a tool. Maybe Vistec had some sort of a tool. And of course, IMS was a very small company. I think there were like 40 individuals at the time. And I liked their design. I liked their design for simplicity. It has a single source. And it had a complex blanker, but it also had a single objective. When you have a single objective, it makes life a whole lot easier. You don't have to worry about how to deflect each beam one at a time. And single source, if you're in the eBeam business like I am for many years, keeping one source running is tough enough. Imagine 5,000 or 256,000.
Yeah.
And I always say this, also the design in a way, it mimicked the Micronic SLM tool.
Oh, okay.
If you think of the Micronic SLM tool, which is, I would say, one of the first successful multi-beam mask writer in the world, it has a single source. They use the SLM, spatial light modulators, to modulate the beams, and they have a single objective. So the task was, how can we take this IMS tool? And oh, by the way, IMS was in love with ion beam.
Right, yeah.
But it didn't take long to converge to eBeam. And then
And you helped them through that thinking process of ion beam versus E-beam?
yeah, I mean, they're very smart. They're very good people, but they didn't have the mask industry experience. And, another thing that it's always true, if you get a good customer, the customer will make you better.
Yeah. And
So simply by us being a customer for IMS, by definition, they were able to become better.
it's kind of like Hayashi-san too.
That's
You were
right,
doing
with
that.
the old days,
Yeah.
And then, but we did something a little bit even more clever than that. I insisted on having multiple customers. And I think
so
that
you insisted.
I insisted.
Right, I see, interesting.
And one of the main reasons when you have multiple customers, in our business, in the mask industry is very small. It's hard enough to be in the mask industry. Now, it's even harder to be in the mask equipment industry. And nobody wants to spend money to develop one or two tools, to develop a tool just to sell one or two. So you really have to be mainstream. If you can't be mainstream, you can't survive. And the idea was, if we can put a consortium together that represents the industry with Intel, TSMC. We brought in the merchants, Photronics, and Dynapon, Hayashi-san. We extended an offer to Samsung to come and join. And everybody sort of had an equal vote. And by having the various perspective, made IMS better and better. So that's how the whole thing started.
Yeah, because the different kind of designs, like microprocessor versus memory versus the TSMC business, they have different demands.
That is correct.
Right? And so
Yeah.
you wanted to make sure that they were all represented so that the two doesn't end up being one-sided.
Exactly,
Right? Yeah.
exactly.
That's
And then there's also a little bit of like, I don't know how to say it, maybe like an emotional piece. If people think that we're making a tool just for us, they may shy away from that supplier. That's why all my projects to develop tools for the industry, for us, but I always make sure that it's for us and for the industry.
Yeah,
Because-
that's very unique, observing as an outsider, that's very unique about how you approach this, right? So it's not just IMS, right?
No.
Laser tech, actinic, other
That's
things.
right.
Like what are some other examples of this?
Well, a long time ago, the Intel mass shop, we received the first eBeam repair tool. At the time, the company was called Noatech, and then they eventually sold to Zeiss. And of course, the consortium we made for the Ames tool from Zeiss, that was TSMC, Samsung, and Intel. And the best example that comes to mind now is the curvilinear data format.
Yeah, that too. Yeah.
From day one, I insisted that we have to have a consortia with, and it was beautiful because TSMC, Dampeng was fantastic. He really puts his heart and time into it.
Yeah.
And Jin Choi
Yeah.
from Samsung, he's going for it all the way.
Yeah.
And then all the CAD companies are very, very supportive, so including you.
Okay.
So in that regard,
Absolutely. Makes perfect sense. But it takes somebody with the vision and conviction and honestly kind of the reputation of success to be able to lead it, right? There could have been multiple different ones. Like in other industries, there would have been multiple different attempts, right? But in the curvilinear format, there is one format, right? And that's really important for its success. But you drove that successfully. You do that on so many different fronts, right? Equipment too. You're just absolutely convinced that Intel having exclusivity or something isn't the right way to go. You need to make sure that the entire industry is supporting. How do you differentiate between, I'm sure you
Yeah.
also want an advantage for Intel, right? So,
Yes,
you know,
yes.
I know you drive that way,
Yes.
with us, for example, right? So, so I know that you do that, but how do you decide, which is which?
Honestly, there is no formula. I can't sit here and tell you like 1, 2, 3, 4. There is no procedure. But there is maybe a theme, or maybe there is a strategy in mind.
Yeah.
Is that we need it. We need it fast. We need it now. And if we go and try to pay for everything, and then nobody else would buy it, and we become the only customer, we run 2 risks. Number one, we run the risk of cost. But more importantly, is we run the risk of having our blinders on.
Right.
And if we have our blinders on, then we're missing a chance. We're missing the opportunity to see what else is out there. So by having us be first, because we need it first. And I know nowadays everybody's talking about, oh, you're falling behind, TSMC is ahead of you. I worry about that, but not so much, because we are not really behind. I know in the mask area, we are right at par, if not ahead. And I don't want to upset anybody from TSMC because they're all my friends, so as Samsung. but I know that we were all at the leading edge. So you want that community, you want that mass community to stay together because it's very small. You want the vendors, the suppliers to want to work with you. And being a supplier for many years, I spent 20 years being a supplier. I know what it's like to run a small company and needing orders. So if they see revenue stream, if they see that the potential is not just Intel, but the whole industry will adopt, then they are more willing and more supportive.
Yeah. It's obviously working right, on so many different fronts. And actually including Bacchus itself, right? The community of people that put together the Bacchus conference in September every year that we just came out of. You were instrumental in putting Bacchus and EUV together.
Yes,
right?
yes.
To give more vibrance, I guess. What was the reasoning behind that, and how did you make it happen?
Yeah, actually, a lot of folks, a lot of people helped with that one, and a lot of kudos go to Jim Wiley and to other folks, but it was driven by a dwindling attendance. And you can't have a conference if you don't have enough people showing up. And our conference was in September, always in September. And this EUVL conference is in October, just around the corner, or November. So it was just too close. And people want to come to Bacchus, but then they want to go to the EUVL. And the EUVL guys for a while were running solo for good reasons, because EUV wasn't well adopted at the time. And there was a lot of research and development and not a lot of interest from mainstream manufacturing folks. So they had to have their own conference. But there became time when we're adopting EUV. EUV is going to become mainstream. The conferences are joining. It was intuitive. Like, guys, we should do this. Paolo Gargini. I give him a lot of credit for helping us with that. Yeah.
It's consistent with your approach to vendors and other formats and things like that too, right? Because you have this instinct for some things you need to do in a collaborative way, even if competitors are getting together to do something, right? It's very consistent at the conference level,
Yes.
right? In some ways, these conferences are competing for attendance, right? But you said, well, let's just put it together, because that'll be better for both groups.
Yeah, and I think it worked out. It worked out well.
Oh yeah, clearly. It worked out, yeah.
But I want to I want to come back to the luck piece, because and as much as we plan and as much as we think, many times luck plays a good piece. And I was talking about the multi-beam writer and why we wanted to do it, because of ILT was going to break the vector shape beam systems. And for a while we were running IMS tool, or the IMS development, and we got our first tool in 2012. We actually built it on site. And it was the first time that anybody would build an eBeam machine, an eBeam mask writer, in the customer's facility. And then later it became the standard. Then we came across EUV. All of a sudden, we got notice from our customer in Oregon, the Technology Development Center, that we need to be ready for EUV in this time frame. And we realized we cannot make EUV masks with the current tools. And the main driver is the resist. To hit the resolution requirement for EUV, you need to have very low sensitivity resist.
Right, slower resist, right?
Slower resist. Well, slower resist requires higher dose. And now on a vector shape beam tool, it would take days. Then we looked at the multi-beam tool that we're working on for ILT, and we realized with all these beams, we can actually get an order of magnitude higher dose. And we tried it, and really it became one of the key drivers that we didn't plan on.
Oh, interesting.
To make EUV masks come to life. So
I see. So the initial thing was actually IoT and curvilinear masks, and
That's right.
And then EUV came along, and we said for a different reason, right? It was because of the way it projects and thermal effects and all that.
That's right.
That it just turns out. I think now people pretty much accept it that if you're going to write a EUV mask, it doesn't matter what shape. You got to use multi-beam, right?
Gotta use multi-beam.
So it turned out to be just absolutely correct, right?
Yeah, yeah.
That's interesting. So you call
An interesting
it luck,
point.
but, part of it is, you make luck happen, right?
Yes, yeah.
So that's great. Yeah, thank you. Let's turn back to where the mask industry is going. Like now EUV is here and it's well established. Now, there's high NA things coming, and there's interesting questions about like a circular mask, and all this
Yes.
stuff is being talked about. But as a general trend, what do you see in the mask industry?
I see growth. I actually see growth, and I see success. Many years back, if you remember, people were asking me like, oh, we have to make EUV masks, it's going to disturb the industry. And I was like, I love EUV masks.
Yeah, okay.
We want to do EUV masks. I want it to disturb the industry because when you have a paradigm shift, there are opportunities. And EUV mask allowed us to have a new suppliers and put money into the mask industry. And all that is helpful, and hire people. We hired so many newcomers. If it wasn't for EUV, they wouldn't be interested in mask. Because all these folks, they go to universities, get their PhDs, they work in EUV programs, and now it's real.
Right.
So I think going to high NA is going to be challenging, but I think we will do it. Not so much a paradigm shift, but high NA is going to require better material. Is going to put a lot of pressure on the blank suppliers. We're going to have to go to zero defects, better materials. We're going to have to go with new writers, new mask writers, because yet another level of higher dose.
Yeah.
Probably, etch, develop, and the metrology will be very difficult because, as you remember, in high NA, we're no longer symmetrical in the in the magnification. Now we have one axis at 4x, one axis at 8x, and you have to be able to tell the difference, and the metrology tools have to be able to negotiate those features. And the fact that it's 8x in one axis, there is no relief. From a mask maker point of view, we're going to treat everything as if it's just 4x.
I see.
Because you have to make the 4x axis work. So you can't control where the defect is going to fall.
I see. And so defects, how about pellicles with high NA? Is that an issue, or is that?
I don't think so.
Yeah? Okay.
I don't think so. I mean, people were scared of pellicles.
Yeah.
I was one of them. I was scared of pellicles when they first came out. But we had such a long, fruitful development relationship with ASML. It goes back more than 10 years in looking at pellicles and how we test them, and we did a lot of work in that area. So I think high NA pellicles is given. It's not going to be an issue. I don't think we're going to hit the ground running on day one, but that's always the case. Then after that, I don't know which way we go. We go hyper NA, which puts even more pressure on the mask,
Right.
or we go to the larger format. But me personally, I welcome the larger format for the same reason I welcome the EUV. Where you do a paradigm shift, it makes the industry healthier, it pumps money into the industry, and at the end of the day, the driver for anything in the mask industry is the wafer fab. If the wafer fab can make more money, then they will ask us to do it.
Right.
The only time we did EUV is when the wafer fab said, multi-patterning is becoming very difficult. EUV is going to be more cost effective. They put the money. It's going to be the same story. when the wafer fabs decide that larger format is cost effective, we'll make it happen.
So all these changes that you see coming will, you think, continue to be healthy for the mask industry, right? These things are going to be even more expensive than now, or there's going to be more of them, or like what do you think?
I think we're going to see more bifurcation of the mask industry. There's the number of masks that are serving 28 nanometer and older nodes is just humongous, huge.
Yeah.
And with the automobile industry, they're keeping that middle node alive for a long time. But you will still see the need for the high end. I think the top three will always be at the bleeding edge. You know, the Intel, TSMC, Samsung. I was very happy at the conference to see Micron jumping into EUV. It's great. And I know that many companies in Korea are doing the same. So, but I think it's all about cost. It's all about money. If the type of mask can save money in the wafer fab, if we can take multi layers and smash them into one EUV print, that's money for the wafer fab. We make it happen.
Yeah, so it's good, right? So we're still in really good space in the mask industry, right?
Yeah.
We got up to $5 billion now as an industry together, and I think it's always just more fun because we can do more things.
Yes.
When we like if it's lean times, we have to pick between this
or that,
right? You know.
Yes.
And now we are healthy enough that we can explore multiple options, I think, together, and that's always better.
Yeah.
So what about Moore's law? There's some talk, about Moore's law is dead and things like that, and I feel like that's not how you're talking about the industry. What do you think about that?
Yeah. Oh gosh. I think Moore's law is far from being dead. And you probably remember when we were at SPIE microlithography. I think they changed the name now. They call it advanced lithography. And I saw a bunch of very reputable engineers in the hallway cheering and drinking beers, celebrating the death of Moore's law.
Oh.
I was watching them from afar going, I don't know what these guys are thinking. And then sure enough, a few years later, one of them came up to me at another conference and apologized, says, that was the wrong thing to do. But my personal opinion is we are committed to Moore's law. I'm personally committed to Moore's law. The innovations that we make are just unbelievable. I don't think there is an end to Moore's law. As long as there is human ingenuity, Moore's law will live forever. And we're definitely in the mask shop. We're doing everything in our power to facilitate what the litho people need. We have mask innovations. We try so hard to be ahead of them, ahead of the need. We try to have mask solutions ahead of the need, so we're not delaying anybody.
Right.
And I tell you, Moore's law for a long, long time.
Yeah, that's great. Yeah, Moore's law forever is what I think too.
That's right.
That's great. Yeah. Thank you. So thank you very much, Frank, today. It's a real honor to be able to ask for your opinions and get a lot of insights that a lot of things that I didn't know about. The connection with your earlier career to being involved in a data path for multi-beam, right? What is now GPU. You were working on that a long time ago. That's incredible. Yeah. So thank you. Yeah. So this concludes today's short talk, and we'll see you next time.